All right, this is the last of the 3 videos for this week, 3.6 nonlinear models. It was a bad hair day for me, so I've got this hat on and we're ready to go. So exponential models, we have talked about this formula in class, and that formula is population in terms of time. You can use A. This formula is using P sub O. So P sub O times your base raised to the T, or the time. Now, something interesting to note is your base, if they give you the rate, then you're going to put in place of the base 1 plus the rate, and the rate will be a decimal. If it's a decay factor, it'll be 1 minus the rate for the base. So we'll be doing that in the story problem. So let's look at this. Example 1, write an exponential function that models the population of Smallville, be like Superman. If the initial population was 2,853 and it decreased by 2.3% each year, predict how long it will take for the population to fall to 2,000. So we're using an exponential function. So this is our model that we'll be using. We're going to plug in what we know. So we know P sub O, that is the population, 2,853. We know that it's dropping at a rate of 0.023. Move this 2 places to the left. And so our base, because it's decay, the population is dropping, our base is going to be 1 subtract the rate, which is 0.023. And that's going to equal 0.977. So then what we can do is we have population in terms of time, and let's go ahead and write the function. So it's P sub O, or A. And you guys, this first number in exponential equations is your y-intercept, or your initial value. So 2,853. And then we are going to multiply that by, so should we use parentheses? The 0.977 raised to the t. So that is your function. Now, the question is, how long will it take for the population to fall to 2,000 people? So we want to figure out what t is. So what you can do is you can take your graphing calculator and you can go to y1 and you can plug in this equation. In place of t, put in x, and then you can plug in under y2 2,000, and then what you want to do is look for the intersection, and the intersection is going to be your solution. So where those two intersect, you would look at the x value. So the intersection is going to be at 15.266, which is about 15 years. All right, so that's how you would do it with the calculator. Let me show you how you would do it by hand if you're interested in doing it by hand. So by hand, population in terms of time, we want to see when the population drops to 2,000. So you would put 2,000 equals, and then you would have the 2,853 times the 0.977, and then raised to the t. And what you would want to do is solve for t. So how you would solve for t, this is really important, is do not multiply these two numbers, because this number is being raised to an exponent. In order of operations, we do exponents before multiplication. So what you're going to do instead is divide the 2,853 over here to the other side. All right, so once you divide that, you get something like 0.701. And again, I would recommend store using the full number. So maybe arrowing down, grabbing that full number in the end. And that equals 0.977t. Now, how story problems work is if we're trying to figure out this value up here in the exponent, then I want to be able to bring this exponent down in front. So you're going to take either the logarithm or the natural logarithm of both sides. Doesn't matter whether you do log or natural log. And then I can use my power property of logarithms, which allows me to bring that t down in front. And so this gives me ln 0.701 equals t ln 0.977. And now we want to isolate t, and this is all multiplication. So you would divide by ln 0.977 to both sides. So divide by ln 0.977. And then you can see I isolated t. If you put this into your calculator, the ln key is just to the left of the 4. And I would use a fraction bar, green alpha, F1, or the y equals. And you're going to get this 15.266. So example 2 is the population of ants is increasing exponentially. Ooh, that did not work. Exponentially. So we're going to use an exponential equation. On day 2, there happens to be 100 ants. And on day 4, there happens to be 300 ants. How many ants are there on day 5? So we're going to use population in terms of time equals P sub O, or A times B raised to the T. So that's going to be our equation. We are going to have a system of equations, which means we're going to have 2 equations in 2 variables, and then we can divide those 2 equations to get our answer. So let's start with day 2. So on, actually, let's start with day 4. I like to start with the bigger one first. So on day 4, 300 ants is equal to, and then we have A times B raised to the 4th power. So T stands for time, and there's 4 days. The second equation, we have 100 ants. We don't know the initial population. We don't know the rate at which it's increasing, but we do know that this was on day 2. So now we're going to divide the system. So this works out really nicely because the A's will cancel. It's all multiplication. 100 into 300 is 3 equals, and then b to the 4th divided by b to the 2nd is b to the 2nd. All right, and then how we get rid of b to the 2nd is you can square root both sides, or you can take both sides to the 1/2 power. And so b is equal to 3 to the 1/2, or the square root of 3. All right, so that's going to be your base. I will go ahead and approximate it for you. So the base is 1.732. All right, so now what we're going to do is you'll plug this in and figure out what A is. So we know what B is. Now we're going to figure out what A is. So A is going to be, just pick one of the 2 equations. So 100 equals A times. Now I would have stored this number in my calculator as B, and then I would use the full number. So that's what I would do. But it's A times B raised to the 2nd power. So you would square that and then divide it over here to the other side. And that's going to give you what A is. So let me use my calculator. So again, I would use the store key on your calculator, store A and store B, and then you're going to actually do the problem, which is how many ants are there on day 5? So it would be y equals A times B to the 5th power. These numbers get plugged in on your calculator, and you're going to round. You always round down to the whole number, so 519 ants is what you end up with. Make sure you try this one on the calculator. So we're going to skip example 3, the regression example, and go to radioactive decay and half-life. So radioactive decay is the process in which the number of atoms of an element change from a radioactive state to a non-radioactive state. I know carbon dating has radioactive decay in it. That's when you have C14 in your body and you're always producing a certain amount of carbon-14. When you die, you no longer produce that amount. And so what we would do is we could look at the bones and determine how much C14 is left. Based on the half-life, we could predict the age of the bones. So carbon dating has to do with radioactive decay and with half-lives. Half-life is it's how long it takes for half of the sample to go from radioactive to non-radioactive. So example 4, the half-life of radioactive strontium is 28 days. Write an equation, predict the amount of a 50-gram sample that remains after 100 days. Now, we are going to basically use this same exponential function, except for, let me just make a couple of changes to it. So P of T is just standing for how much of that substance is left over time. P sub O is the initial amount of the substance. So you'll take the initial amount, you'll multiply it by the half-life. So the base of a half-life is always a half. And then you're going to raise it to the time that goes by divided by the half-life time. So the half-life is how long it takes for it to be cut in half. So looking at this problem, we're going to be looking for P of T. The initial amount is we're starting with a 50-gram sample. Our rate is going to be a half-life, so it's a half. And we're going to raise that to, it says it takes 28 days for it to be cut in half, and we want to know how much is left after 100 days. So the larger number is going to go on top. We have 100 days is your time, and the half-life that it takes is 28. So you're just going to throw that all into your calculator, and you are going to get, there is 4.206 grams after 100 days left. So here's a new formula for you. This is the logistic function. I always think of the C at the top. So here's your C. I always think of this as ceiling. So this is where your function hits that top asymptote. So it hits its limit at the ceiling. And I don't know why it did that. The limit to growth is your ceiling. And then 1 plus A, your initial amount, times B, your base, raised to the X. The logistic function looks like this down here. The domain of this graph down here is going left and right forever, so negative infinity to infinity. The range, my pen is freaking out a little bit. The range, it goes, there's asymptote at 0 and an asymptote at 1. This is a bounded function, and so the range is going to go from 0 to 1, and you're not going to include those, okay? So it will always be increasing closer and closer and closer and closer to the asymptote. Don't know why, what's happening. All right, I have a ghost. Horizontal asymptotes. So you have, now I dropped my pen. Oh, must be getting late. Help me. So horizontal asymptote is going to be y equals 0. That's this bottom one. And y equals 1 is the top one. And I have no idea why my board is freaking out, but I think that that text will be just fine. So logistic functions, there may have been a question on the other page asking you what would limit the function. This is going to be your resources. So like food, timber, shelter, water, space, land, all of that is going to create, you've got an exponential growth in population, but then that population curves off because you don't have any more room for more people. This is the formula here of the logistic function. It looks super complicated, but it's not. The top number is the maximum amount of people. So that's always really easy. Estimate the maximum population for Dallas. Okay, so maximum population is that number right there. Now it wants to know what the population is going to be in 2008. And so we're going from 1900 to 2008. So that's 108 years that went by. All right. So what we're going to do is we're just going to take this kind of complicated looking function, and in place of time, we're going to put the 108. So we've got 1301642. 1 plus 21.602e raised to the negative 0.05054 times 108. I highly recommend using the fraction bar, green alpha F1, enter. Otherwise, you're going to need parentheses around your denominator. Throw the whole thing in your calculator to make sure you know how to use your calculator, and you're going to end up with 108. If you're wondering where the E is, you hit second ln. ln is to the left of the 4. So E is at second, and then ln on the calculator. Make sure that you use the negative at the bottom by the decimal. Don't use a subtraction. You really should put this in the calculator to make sure that you can get that answer. Let's see. Population. Why did I say it's 108? Oh my goodness. So, you know what? I'm too tired to start over. At this point in the game, throw this all into your calculator. And the years that went by was 108, but the population, wait for it, is in 2008, we have 191,936 people. And notice it's smaller than the ceiling, because the ceiling amount, you can't have more population than this top number. So the asymptotes of this are going to be, if they asked for the asymptotes, you'd have 0 as your bottom one, and your top asymptote is 1301642. Thanks, you guys. So here is a logistic function, and it just says state the y-intercept and the horizontal asymptotes. So finding the y-intercept is pretty easy. How you find the y-intercept is you plug in 0 for x, because when x is 0, what's y? And it really does look like it's 1, but you could do it algebraically. So it'd be 3 over 1 plus 2 times 0.4 to the 0 power. Well, 0.4 to the 0 is going to be 1, and 1 times 2 is 2. So that gives me 3 over 1 plus 2, which is 3 over 3, which equals 1. So the y-intercept is 0. Looking at the horizontal asymptote, the horizontal asymptotes are y equals 0. That's this asymptote here at the bottom. The asymptote at the top is always your ceiling. So the asymptote at the top is y equals 3. And those are your horizontal asymptotes. Again, how do you find the y-intercept? Plug in 0 for x. So Here, I took X, I plugged in 0. Common mistake on this problem is order of operations. Do not, maybe parenthesis would look better here. Do not multiply these two numbers. That's the mistake I see. So what you're going to want to do is take the number to the power first, then multiply, then add. So following order of operations. All right, hi everyone. We're going to do writing a logistic function. I'm getting tired, so let's get this done. Finding the logistic function satisfies the conditions. The initial value is 40. That's where A goes, initial value. The limit to growth is 100. That's your ceiling. All right, so that's your top number where the asymptote is. It's going to pass through the point 110. 1 will be your X value and 10 will be your Y value. First thing you have to do before you can write the function is figure out what B is. So here is your function, and you're going to plug in A, B, and C, and then you'll have your function. But before I can do that, I need to know what B is. So what I did is I did Y, which is 10, is equal to 100 over 1 plus 40 times B raised to the first power, because X is 1. From there, you just have to solve that. So I did some cross multiplying. You could also multiply both sides of the equation by the 1 plus 40B. Instead of distributing the 10, I decided to divide it to the other side. So, and I'm missing a 0 here. There we go. So this is going to be 100 divided by 10, which is 10. So now I have 1 plus 40B equals 10. So 40B equals 9 when you subtract the 1. So B is equal to 9 over 40. All right, so now I am ready to write the logistic function. So writing the function, we have to plug in C, A, and B. And then you've written the function. You want to leave X and Y because those are all the X, Y values along the function. So what's the equation? It is f of X equals 100 divided by 1 plus, you will plug in A, which is 40. You will plug in B, which is 9 over 40, and you will raise it to the X or T, whatever. We did f of X, so it would be X. If this were f of T, you'd put in T. All right, now I know some of you are really tempted to cross cancel those 40s. No, 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 don't do it. Very bad, because that means you'd be multiplying before going to the power. So that is your function, and that is everything. So thanks so much. Have a really nice day. If you will answer the reflection question, you should be good to go.